Hi everyone, Mr. Eric Kwa here, founder of Mr. Khemistry. Hope you're enjoying the videos that I've made for you specially. Remember to tap that like button and to click subscribe and to share with your friends if you found any of these videos useful or interesting. I look forward to seeing you around. Let's get started with today's topic. Hi everybody, today I want to go through with you a quick check question so that you can see how Hess's law is actually used in application. Okay, so this quick check, we start off with the reaction equation right here, given to us. They say that the enthalpy changes of formation calcium fluoride, sulfuric acid, HF, and calcium sulfate are given respectively. So they want you to find the delta H for this reaction itself. Okay, so as with any case, right, when you are given the enthalpy change, you must take note of what is the enthalpy change you are given. In this case, it is formation. So what does delta H of formation entails? So basically, formation says that it is the formation of 1 mole of that particular substance from its constituent elements. Okay, so if we were to draw an energy cycle for this question, we don't have to, the question didn't ask us to, we can apply the formula. But in this case, I'm just going to draw the energy cycle so that you can see, in fact, how the formula came to be. Okay, so here, let's write out the whole equation again, the AIM equation, calcium fluoride plus sulfuric acid gives you 2HF and calcium sulfate. Okay, so if you put in your equations, right, remember each one of the enthalpy is actually a standalone equation by itself. So if I were to write an equation, right, the equation for formation, for example, of calcium fluoride, it will be calcium solid plus fluorine gas to give you 1 mole of calcium. Okay, so this reaction, right, I'm going to piece it into this energy cycle. So let me just take this, write it at the bottom, calcium solid plus fluorine gas. That will give to us 1 mole of calcium fluoride. Okay, so this enthalpy change of formation is given as negative 1220 kilojoules. Okay, so that's one. The second one that we will do is actually sulfuric acid. So your molecules, elements are actually hydrogen gas, sulfur, solid, and 2 oxygen gas. Okay, so from here, we're going to put up to the sulfuric acid. That will give you negative 814. So these two, we have actually already used them. The two enthalpy change of formation. Okay, so now we're left with the third one, right? The third one is hydrogen fluoride. Hydrogen fluoride, you already have the elements present, H and F2. So we're just going to put this arrow here. But take note, right? Enthalpy change of formation is for 1 mole of substance form. So here we have 2 moles of substance form. That's why we need to put a 2 in front of the 271 kilojoules per mole. Okay. And the last one is calcium sulfate, which will be this way, minus 1434. Okay, so as always, the Hess's law, right? What does it say? It says that the enthalpy change is independent of the pathway taken. So if this was the first pathway, this is the enthalpy change that we want. Okay, this is the first pathway. The second pathway will look like this. Okay, so if you look at the green color arrow versus the yellow color arrow, you notice that these two, right? These two values will have to flip. Okay, you have to add a negative sign in front of them. Okay, so essentially, how do you calculate the delta H? Do it by Hess's law. Let's bring this up a little bit. By Hess's law. Okay, the green arrow, right, which is your delta H reaction, which is the inequation, the delta H that we want. Delta H reaction is equals to minus 1220 minus 814 plus 2 times minus 271. Yeah. Okay, so when you write out this is actually the most critical part, yeah. When you write this out, is based on the yellow arrow, the yellow pathway, alternative pathway. Okay, so you just key in that all these values, making sure that the directionally is correct, making sure that the number of moles is correct. See, we must remember to put in the 2 in front here, right? Yeah, and then you do the calculation, you should be able to get 58. Okay, maybe let's do the calculation together. So if we have 1220 plus 814 minus 271 minus 271 minus 1434. Yep, so answer is 58 here. I'm sure you have a better calculator than mine. You should be able to do that faster. So this is the example of how we would actually calculate and use the energy cycle to calculate enthalpy change. So that's all for today. I hope you have learned something. Please remember to like this video and share it with your friends who may also benefit from this. See you in the next one. Bye bye.